All right, finishing up 8.7. We're doing example 6. And this is very tedious, this one. It says, given that the integral from 0 to 1 of x e to the negative x dx is equal to 1 minus 2e to the negative 1. They are actually giving us the answer. This right here is the exact answer. And the reason we need to know that is because they want us to find absolute errors. And if you remember from the beginning of section 7, absolute error is c minus x, where x is the exact solution and c is the approximation. And it doesn't really matter which way you do it because you're going to do the absolute value. But you're going to take your answer and you're going to subtract the 1 minus 2e to the negative 1 to get the error. And it says to do it with trapezoid and Simpsons with n equal to 8, 16, 32, 64, and 128. Yeah, that's crazy nonsense, that one. So the way we're going to do it is, the reason they have these numbers is because we're going to use that Simpsons rule that says if I'm trying to go twice as high as where I am, I take 4 times the trapezoid's approximation at twice as high minus the trapezoid at n over 3. So we start out with, we're going to start out with n is 4 to do this. If n is 4, our breakdowns, and the book doesn't give us any of this information, but we've got to work out this part first. We're going from 0 to 1, so delta x is going to be 1 minus 0 over 4, so each one is going to be a fourth. So using the trapezoid rule for 4, and trapezoid rule is the one that has the first one stands alone, the first x, and then everyone gets a 2 after that, and the last one stands alone. So I have 1/4 for the width of each trapezoid. So I'm just going to put that out in front. And then we need to find out f of, the starting point is 0, plus 2f of 0.25, plus 2f of 0.5, because I'm jumping by 0.25s, plus 2f of 0.75, and then it stops at 1, so the last one doesn't have a 2 in front of it. Remember, we're using the formula 1/2 the height times the sum of the two bases. And, oops, I forgot the 1/2. So there it is there. So now I have 1/8, and then I've got to get all these numbers. Now, you have to go to your calculator for this. The easiest way to do it is to put x e to the negative x in for y1. And then go to your table or use your var button on the calculator. You can pick var, pick y1, and then in parentheses put the number you're sticking in, for example 0. When you stick 0 into this function, you do get 0, so the first one's a 0, plus 2 times, and you continue on. And I'm going to pause this and get my numbers so I can fill them in. Okay, and to get to that y1, you actually have to, when you hit the var button, you're going to have to move over to the, let me check, to the y vars, and then pick function, and then you can pick y1, and then put your parentheses in. That gets kind of cumbersome. There's an easier way of doing this. The easier way would be, and I can't remember if we set up our table or not, so I'll remind you how to do it. Go second window. I'm going to write it down the margin here. Second window, and change your independent, using their initials, to ask. Move over to the ask and click on it so that it, and hit enter on it so that it gets bolded. or put a block around it. Then second graph will take you to the table, and now the table is blank, and you just type in what you want for x. So you type in 0 and you hit enter. And then you type in 0.25 and you hit enter. And what's going to appear in that next column, the first column is x, the second column is y1, and all the numbers appear. So when I did that, I got 2 times 0.25 was 0.1947. And then I got 2 times 0.30327. And then 2 times 0.35427. And then 0.36788 with no 2 on it, because it's the last one. And then we had to put all of those together. And I got 1/8, and all of this nonsense gave me 2.07236. And then I got 0.259045, which would be that first thing in the table that's on page 551 in the book for Tn, when n is 4. Now the exact answer, if you put it in your calculator, and I haven't put it in yet, let me look and see. The exact answer, according to plugging in up at the very top of the page I'm writing this exact answer, obviously rounded, 0.264241177. So my error is going to be the difference between those two. I'm not sure why I only got 6 places. Let me look. Oh, I know why I didn't see it all. When you're writing down your answers up here, move the cursor on top of your answer for Y1 so you get more decimal places, because it's only going to show you 4, and there's a whole slew of places. So we won't worry about it now, but anyhow, you subtract them, and when you subtract them, you should get an error of 0.00520. Then you're going to go down, you're going to write it for T of 8. So now you have your delta x is 1 minus 0 over 8, so each one is an eighth. So now you're going to have 1/2 times 1/8 function at 0 plus 2, the function at 1/8 plus 2, the function at 1/4, that's 2/8, and then 3/8, and then 4/8 is 1/2, and then 5/8, and then 6/8 is 3/4, and then 7/8, and then the last one does not get a 2, and you put all that in your calculator. Now if I just write down a few numbers here so we have it to work with. If n, here's T of n, here's S of n, the error of T of n, and the error of S of n. Okay, we did n was 4, we got 0.259045, more stuff. Then the error, we ended up with 0.00520. Then we went down and did 8, and if you do 8, I'm just going to copy it out of the book because I'm not going to sit here and do all these. Lots of places. 0.2629398, and the error turns out to be 0.00130. Now here's the thing we want to do. We want to figure out S of 8. Remember, this is your 2n, so in this case you're talking n is 4, and according to the rule, S of 8 would be 4 times the trapezoid at 8 minus the trapezoid at 4 over 3. So I'm going to read the numbers right off of here. It's going to be 0.2629398, and then minus 0.259045, and the whole thing is divided by 3. And when you do that, you now have your S sub 8. And and if you put that in your calculator, you should get 0.264238 stuff. So I'm going to put that right here, 0.264238. If I subtract that one from the actual answer, my error is getting really tiny really fast. There's the error. And then you're going to continue on. Now you would figure out t of, what's the next number? 16. Get that one. Once you have t of 16, then you can figure out s of 16. Because s of 16 would be 4 times t of 16 minus t of 8 over 3. So they just keep compounding on top of themselves. And if you make a mistake in this, it's going to mess it up all the way down the line. So you've got to be very meticulous about it. There are also formulas there for the errors in numerical integration, and it's beyond Calculus II, so we don't necessarily have to do that. But you keep following this same process. There's a question in My Math Lab that asks you to find out how far you have to go, how many terms you've got to go out before you get an error less than 10 to the negative 3, I think it says. So 10 to the negative 3 would be 3 zeros, 0.000. And so in this particular case, it would be 8. If I went out 8, Simpson's rule would be an error less than 10 to the negative 3. So this concludes Section 7.